Oh, God.
So here is the data put into the calculator. Oops. Did everybody get a chance to do that aspect, put that data in there and sort it? Take a minute right now and put all that data in your calculator and sort it. Huh? Yes. If you think that's a lot, oh, I feel bad. Oh, since you're going to create a visual, just like this one. Oh, I'm with you. And what's interesting is you see how technically can't include 79. Whenever you use exactly this number, it's not going to include the last thing, but we're allowed to suck it in. It's right on the edge anyway. So it's not like we're lying or it's just sucking that one data point.
Is it always in play classes?
No. So it's not, because I do this. A relatively small sample.
Right.
So I used 5 classes. If I had like 3 times that much, I might do 6 or 7 classes.
Oh, that's right.
Will it tell you or you make it?
On the quiz, there's nothing I won't tell you. For this one, I just kind of gave you numbers. So, I'm not going to give a crazy number. So I would never use 8, 9, or 10 classes in here because I'm not going to give you so many data points. There's actually a formula that involves logarithms of the number of data points, and I just don't work with that. Where smaller ones use 5 or 6, bigger ones use 7, 8, really big ones 9, 10. Okay, let me know if you're having any trouble with sorting, especially if you weren't here yesterday. So you got it all in there? Okay, so now hit stat. We want to sort ascending. And tell it second ones for L1. Now go back in. Is that edit? Oops. Now it's oh, well, press up here. So I like the list because you want something to do the whole list. Clear, enter.
My first time
Oh.
Here, I'll just give you. Here. Is it batteries or is it?
Yeah.
Oh, no. Okay.
Yeah, you're under that.
So it's supposed to say 66. No, he's just on 66. Yeah. No, you're good.
All right. Yes. Huh? Okay. Once you get all your data in, you hit stat. We normally use sort A for sort ascending.
There you go.
And then you have to tell it list 1. So you hit second one to tell it list 1. It's always anticlimactic, or almost always. You got to go back in the list and you go, oh wow, it's on order. Neat. Wait. You don't have to react like that. Okay. This is, while some of you guys are finishing up, this is what we talked about yesterday, the physical idea behind this formula. And this morning we talked about you don't actually have to round. It's just something we do to make it easier to look at and work with. Normally we do start at the first data point. You don't have to. So like if I had a class with a 10, I might start at 60. Just make it 60, 70, 80, 90. Does that make sense? So you have to start at a number that is below your first data point, so your first data point has a place to go. Your last number here does not have to do anything with the last data point except it's got to be bigger than it or equal to it, so it's got a place to go. Does that make sense? That's why we round up so that it covers more, so that the last data point has a place to go. Aw. Okay. All right. Is everybody caught up to me now? Let's see. So now that if I can find, there we go. I can get the frequency. And again, the frequency is not 3 or something for all this. The frequency is how frequently I see a data point that is in this range. Now what's the other way, real quick, before I get too far away, what's the other way to do the classes, if you want to? 61.
Is less than or equal to X.
Yeah, 65. See, then, if you do it this way, the boundaries are the limits, they're the same. When I make my histogram, I could use 61, 65, 69. If you do this way, oh shit, you better go down a half, up a half, so there's no gaps. You have to. So that's the trade-off. Either you do this, which is nice whole numbers, there's no inequalities, there's no x's, but you do have to make it up and down by a half. What are you going to make? Or you can do this way, where the numbers are always nice, but you have to have these inequality symbols and understand them and put them in the right direction and all that kind of stuff.
Is it option to ask?
Totally. That's why the or, right? You do this or this. Which people do I like better? I don't. You just do whatever way makes more sense to you. Right? So how frequently does something from 61 to 64 show up? Twice. So 61 twice. Finish that out. Oh. What happened?
How do this on the Inspire CX?
No freaking clue. So, like I said,
I'll show you.
there you go. All right. Let me catch up to you guys. What did you guys get for this second class?
11.
11? Yeah. Everybody got 11? Sweet. And what about this third class?
13.
13. The fourth class?
7.
7. And 2. Now how do I check real quick right now that I'm on the right track? Yeah, if you add them up, it better come out to be 35. 13, 26, and 9 is 35, thank God.
No, I'm doing it.
What really sucks is when you're one off and you're like, oh my God, which one did I miss? But when you put it in the calculator too, make sure that the last filled spot is the right spot, right? Because if you put the data in incorrectly in the first place, you're never going to make it work out. That's the 35th spot. It's supposed to be 35 numbers. Thank God. Everybody cool? In fact, do that before you sort the damn thing. It'll make it a lot easier to figure out what you're missing. Okay, how we doing? Everybody with me? Yes? All right, that's the next step. But I want to make sure everybody's cool with those first. Oh yeah, you're like, come on, keep going. All right. So what's relative frequency?
By the whole number.
No.
So 2 data points out of 35 showed up in the first class. So what we say in English is what we do in math. Thank God. So 2 out of 35, which is 0.0571. Sure.
It's round to 4 decimal points.
Oh, we can make this, since we're going to do this by hand,
We can just make this 5.7%. Now please, everybody remember how to change from decimal to percent and vice versa, right? Percent number will always be bigger than the decimal number because the percent number has not been divided by 100 yet. So you move it over twice, make it bigger. No, yes?
What if it adds up to like 99.9?
You're fine. If you have to round, we just rounded. So it's possible that it doesn't add up to 100%, which is fine. Now, if you get something that adds up to 97%, that's too far off, right? Something went wrong. So what's 11 out of 35?
31.43.
31.4? 13 out of 35? 37.1? Just add these together, see that? 2 and 11 is 13, so that and that is that. Yeah, you know math, Jeff. 7 divided by 35, 20, because that's 1/5, which is 20%. And then 2, we already know. Bam!
Real fast, so with the other way, how do you actually write it out for that? Would you just write it out, the x, like less than or equal to x, utility one more time?
Oh, yeah,
Great, thanks.
sure. That'd be like 65, less than 69. So you can see the 4 here.
Yeah, okay, that's all.
Yeah. Here, if you do it this way, you can only see it this. See, there's 4. There's 4. There's 4. That's how you check. The biggest mistake is somebody does this, and then they make 61 to 65, 66. Oh shit, you used 5, and you said you were going to use 4. You're going to lose points, right? It's not like when you lied. I'm going to use this, and then I did. So how do I do cumulative frequency? So far, how much have I collected? 5.7. Now, how much have I collected so far? 37.1. And now I add that to itself, and I get 74.2. Add 20. Add 5.7. Why are we cool with that not being 100, like I just said? We had to round. So, sorry. This one? Or this whole thing? So as I move down through this, how much of the data have I collected so far? 5.7%. Now how much have I collected? This plus this. It's cumulative. It accumulates as you go, like falling snow. Right? So now I wait a little bit. I collect this much more, so now I've got a total of 74.2%. Now I add the 20, now I got 94.2%. Then I add that, and I get this. I should always end up close to 100%.
Can I do like add the frequency each one to each other and divide by 25? Like for example.
Yes, the same thing.
The same.
Yes. I like it. Mathematically, it's the same thing. Like, is everybody? Yes.
Do it the other way, you end up with 100.
Oh yeah. Because if you do it without making it decimals, now here's real quick. Just suffer with me for a second. And you're like, that's all we do, Jeff. 2 out of 35. I wrote that equals 0.0571. Is that really true? When you did 2 divided by 35, did it stop?
No.
No, it didn't. Right? So, but we know what I meant. I should put a little approximately, but oh well. Right? So, which one is exact? 2 out of 35 or 0.0571? 2 out of 35. People say 0.0571 because you're like, that's a lot of decimals, like Spock would say that shit. No. The exact answer is 2 out of 35. 0.0571 is an approximation because I stopped. Right? I rounded it. You guys understand? So if you don't make it a decimal, you're not rounding at all. It'll always come out to be 100%. But we want percentages so that I can actually make the scale make sense. Does that? Yeah? I want the scale to be percentages. Okay. Now right here, what kind of histogram am I asking for? Relative frequency. So what numbers am I going to use? Probably these. I could ask you to make a frequency histogram, in which case you better use these numbers. So just pay attention. So everybody did that.
Say that again?
So here I'm asking for a relative frequency histogram. So what numbers am I going to use to make this scale the relative frequencies? If I ask you for a frequency histogram, you better use these numbers. Yes, cool, I like it. Picture's going to be the same, just the scale is going to be different. So here, this is going to be the rel freak, the real freak. And down here, what's the label here going to be?
Father's height.
Class.
No, it's not specific enough.
Father's.
Yeah, heights of fathers of students. That's plenty. But please, dear God, don't just put classes. That doesn't mean shit. I need specific to the problem. You want to be explanatory to somebody looking at your graph. I'm not going to make you put a title on the graph, but this is going to take place of that title. Now, depending on which way you did it, if we do it this way, which I think most of you are probably going to do, that means you got bad news here. You can't put 61 down. You got to put what? 60.5. Now, what's really nice is what's the class width? 4. So that's 64.5, 68.5, so forth. Just keep adding 4. Huh? What is it, sir? Yeah, if you do it the other way, no, give me a second. Let me finish talking about one way. I'll let you guys, no, it's about my way. If I did it the other way, then I just put 61, 65, 69. See what understanding algebra does for you? Yes?
What's all the way to the end?
Say again?
Like what starts all the way to the end, like on the y-axis? Like you put 61 at the beginning, you put 61 a little ahead of the y-axis. You know what I'm saying?
Should have done there, you wrote the first point you wrote 61 instead of having the origin point be 61.
Yeah, you always want this separation.
That's something that's zero.
Yeah. Unless you actually have 0. Then you can put it right on there. Now, I want you to understand, there's a little symbol that looks like a heartbeat that I'm not going to make you use, but has anybody ever seen that before?
Carry on.
It means that I'm skipping a bunch of empty space. But that's sort of understood when we make this. Yeah. So you need that gap there so that people don't just assume that it's 0. That's what I'm going to think if I see it start right on the axis. I'm like, that must be 0. That's not 0. What the shit? You don't have to put a little heartbeat unless you really want to. Okay. Now, no matter which way you did your scale here, based on how you set up your table, the picture's going to look the same. Okay? So what kind of scale do I want to use here? How high do I have to get? No.
40.
I need to get up, like, yeah. I need to include 37.1%. That's the highest percentage. So let me go up to 40. Why don't you always go up to 100%? Because then it'll be really hard to look at your graph. Your graph might be like, no. I want to make it, I want the highest one to go all the way up, and then I can really see the height differences. If it goes 0 to 100, my whole graph might be, you can't see shit there. Blow that thing up, zoom in for me. Does that make sense? Yeah. So what scale do I use? 5, sure. 5, 10, 15, 20, 25, 30, 35, 40. Yeah. Gotcha. Think about auctioneer or something, I think. Do I have 10, 10? So that first class, how tall will it be? Yeah, 5.7. So just above 5. Bam. The next class, 31.4. Just above 30. Bam. So the next class. 37.1, so sort of in between 35 and 40. It should be the same width, but oh well, Jeff. And then 20%, exactly 20, that's nice. Oh, scheisse. It's good to know how to cuss in several languages. 20%, and then finally another 5.7, so the same height as that one. Pow! Now this is not anywhere near a perfect example of this, and that's real life. But have you guys heard of something called a bell curve?
Yeah.
When you hear your teachers talk about curving grades, they're actually referencing that. Does it look like a bell would roughly fit over this? Roughly. What's kind of wrong about it to be truly bell-shaped? Which rectangle is kind of wrong? This one probably should be a little lower, and then it would be even better. So what's bell curve mean? It starts low, it goes high, it goes low. That would be roughly bell-shaped. If it was also symmetric, meaning mirror image, then it would be bell-shaped, and what we call normal, normally distributed. That's going to be a huge word for us this semester, normally distributed. That is huge. Why is it called normally distributed? Heights are normally distributed. Most people are between certain heights, aren't they? Right? So in the middle, it would look like this. Most people are in there. And then out here, very few people are going to be like 3 foot tall or 7 foot tall, right? And that's what we call those unusual. It's unusual because if you saw somebody who was 3 feet tall, you're not trying to be rude. You're a human. You're going to go, you don't see that all the time, right? Or if you saw somebody 7 foot tall, like I came off a Southwest plane flight and I saw Manute Bol. Anybody know Manute Bol? Does that name sound familiar? 7 foot something or other. Is he 7? Was it 7'7"? Good Lord. You can't miss this man. I was like, that's Manute Bol. And there's a little crowd around him. Well, everybody looks a little next to Manute Bol. Anyway, sorry. So I'm like, whoa. It's because you don't see that all the time. Okay. So any questions from how to construct a histogram? Okay, cool. I like it. You wanna take a break? No, I like some of you guys like just get through this shit. How many of you guys? Anybody want to take a break?
Yes.
So funny. Anybody not want to take a break? Anybody not like raising their hand? All right, you guys, I love you guys. Let's take a break. What the hell? Go back 10:30. I'll give you a little break right now.